This video is about the power and energy use of common items. So I want you guys to start getting an idea of just how much energy some of the things in your home uses up. Starting with light bulbs. So the technology for light bulbs has improved over the years. This slide here shows 3 light bulbs. The first thing I want to point out is the brightness. The brightness listed here is the same for all 3 light bulbs. It's 800 lumens. Okay, so all 3 of these light bulbs are going to be just as bright for whatever you need to do with a light bulb. So why should you buy one versus the other? Well, I'm going to start with the left-hand side one. This is called an incandescent bulb, an incandescent light bulb. When I was a kid growing up, most of the light bulbs in my house were incandescent light bulbs. And you'll see that this one has a power of 60 watts. A power of 60 watts. So that's a measure of how fast it's using up electricity. And you'll notice that this number is a lot higher than the other 2. Okay, so the next one is a CFL light bulb, or in other words, it's a fluorescent light bulb. So this fluorescent light bulb, to get the same amount of brightness, the fluorescent light bulb only has to use 14 watts compared to the 60 watts of the incandescent. So it's a huge, huge savings of electricity. Most of the light bulbs in our school, in our classroom, are fluorescent light bulbs. And then the newest technology would be the LEDs. So these ones are going to be the most energy efficient. So to get the same amount of brightness, the power has dropped down to just 12 watts. Okay, so we're using even less electricity to create our brightness. Now, the lifetime of the bulb is also really different for the 3. You'll see that the LED light bulb lasts for 50,000 hours plus, whereas the fluorescent bulb lasts for 10,000 hours. And the incandescent light bulbs, the old ones, only lasted for about 750 hours before you have to replace them with a new one. So when you go to the store and you're choosing which light bulb to buy, you want to look at, first of all, how many lumens it is. Okay, because how many lumens it is will tell you how bright it is. But let's say you find 2 light bulbs that have the same amount of lumens. Which one should you buy? Well, then you look at the other factors, but the major thing is that the LEDs, the price tag is going to be a bit higher. You're going to have to pay a bit more money to buy the light bulb. But you have to understand that you're going to save a lot more money because it uses less electricity, and because you do not have to replace it nearly as often. Okay, those 2 things save you a lot of money, way more than the extra little bit that you'll have to pay to buy the light bulb in the first place. Here's an example of a package of light bulbs, and I just want to point out the labeling. So light bulb packages are always going to be labeled with the power, how many watts it uses. And it's a little confusing these days because they report 2 numbers. This says 100 watts and also says 23 watts. So which is it? If you read the full sentence, it says 100 watt replacement using only 23 watts. So these light bulbs, they actually only use 23 watts. And what it's trying to say is it's just as bright as an incandescent light bulb that's 100 watts. Okay, so this is a fluorescent light bulb in this picture, and it uses 23 watts, and it's just as bright as the 100 watt incandescent bulbs. The other major thing that will be labeled is the lumens. The number of lumens, how bright it is. This is 1,450 lumens. Okay, so it's brighter than the ones on the previous slide. All right, Now I'm going to shift the attention to larger appliances. So larger appliances are going to be labeled with these things called Energuide labels. So by law, companies trying to sell these appliances have to provide this information to the buyers. So some appliances might include like dishwashers, refrigerators, freezers, washing machine, drying machine, stoves, and ovens. Okay, all of these, whoever's selling them to you needs to provide you with this Energuide label. So this label I have here is one for a refrigerator, and you'll see that there's all sorts of information here, but I'm only going to point your attention to two pieces of information. The first one being the big number right in the middle. So if we read it, this says 554 kWh per year. So you need to review what kWh means from the previous lesson. Do you remember? kWh stands for kilowatt hours, and it's a measure of energy. So this is how much energy this refrigerator uses in 1 year, approximately. Okay, approximately. If you accidentally leave the refrigerator door open for a long stretch of time, well, then the refrigerator is going to have to work really, really hard to try to keep things cool, and you'll probably use more energy than what's listed in this label. All right, the second big piece of information is this little arrow here, and this little arrow is pointing to a place on this scale. So this scale shows you the range of energies used by similar products, or similar refrigerators in this case. So this is trying to say that there exist similar refrigerators out there that only use 481 kilowatt hours in a year. There also exist similar refrigerators that use 683 kilowatt hours in a year. All right, so this just gives you a visual idea of how this refrigerator compares to other similar ones in terms of how much energy they use. I'll give you one more example. So this label here is for a clothes dryer. So you'll see that it says it uses 800 kilowatt hours per year. Now this 800 is a number that is obtained under controlled testing conditions. Not every family is going to use 800 kilowatt hours with this clothes dryer, okay? Because, for example, some families are much larger than others. They have more members of the family. So then they're going to have to do a lot more laundry. And if they're doing a lot more laundry, then this number is probably going to be way more than 800. Whereas other families may just be a couple, like my wife and I are just two of us in this house. So we're probably doing a lot less laundry than the average household. So our number, if we use this dryer, would probably be a lot less than 800 kilowatt hours. Okay, so that's one thing you have to understand. Secondly, let's look at the scale. So this arrow is pointing, towards the upper end of the scale. Okay, it's saying that there's similar clothes dryers that use as little as 400 kilowatt hours. And there's similar clothes dryers that use upwards of 966 kilowatt hours in a year. So this one's at 800, so it's near the higher end. So you may think, oh, well, I'm not going to buy it then. Why would I buy this one that uses higher energy when I can find a similar one that uses much lower energy? Well, you have to take other factors into consideration. For example, the price of the actual clothes dryer. Maybe this one costs $1,000, and the one that uses less energy costs $2,000. well, that's going to factor into your decision on which one to buy. And also, you're going to want to read reviews. You're going to want to read reviews of each clothes dryer to see what other people who have used them have to say about them. Okay, maybe certain clothes dryers are nice and gentle on the clothes so that they do not wear out if you dry them more and more in the dryer, whereas other clothes dryers, maybe they're rougher on the clothes and they'll cause the clothes to wear out more as well. Okay, so you definitely want to do your research on all the products. Okay, do not make your decision just on the energy usage. Research other things as well. All right, one last thing I want to do, just for fun here, and also because towards the end of the week, I'm going to get you to do some of these calculations as well. So you might have to look back to this video when you get there. If you were to leave one of these LED lights on 24 hours a day, how much energy will it use in 1 year? All right, so I put a little red circle here because sometimes it's hard to find, but I'm circling how many watts it's using. So it's using 12 watts. All right, and then this is kind of a review from the previous lesson. We have to calculate how much energy, we're asked to calculate how much energy it uses in a time of 1 year. Okay, so 12 watts for 1 year, calculate the energy. So the first thing you have to do is convert the given information to the proper units. So the formula requires the power to be in kilowatts. So I have to take 12 watts divided by 1,000, and that gives me how many kilowatts it is. It turns out to be 0.012 kilowatts. The time needs to be in hours. So I need to figure out how many hours are in 1 year. How many hours are in 1 year? Well, to do that, you take 365, which is how many days are in a year, and you multiply it by 24, which is how many hours are in a day. That gives me 8,763 hours in a full year. So now I'm ready to calculate the energy. So the formula for energy is power times time. So it's these two numbers here multiplied together. And I'll take a calculator out and I multiply them together. And I come up with 105 kilowatt hours. That's how much energy this is an LED. If you read down here, this is an LED light bulb. This is how much energy this LED light bulb would use in 1 year if you leave it on all day, every day. And if you go back and you compare it to, for example, the fridge, remember the fridge was about 550 kilowatt hours for a full year. So that's how much energy is in comparison with the light bulb if you leave it on for a full year compared to a fridge for a full year. All right, so there's a Google form where you can kind of check your understanding of some of these concepts and then move on to the next lesson after that.